Chapter 9.7 Literal Equations. Okay, a literal equation is an equation that contains more than one variable. So there's an equation, and that equation has 1, 2, 3, and so on variables. So more than one variables. So let's try this one. Here's an equation. Solve this equation for I. It says solve it for I. That means, okay, we will rewrite the equation. Okay, this means, okay, solve for I means rewrite the equation so that it looks like I equals something. Okay, rewrite the equation so that I should be on the left side of the equation, and then the right side of the equation will be the solution for this. So always, if there's only one variable, then solve that equation means rewrite the equation with that variable. So the variable will be on the left side, and then others will be the solution. So let's rewrite this so that the left side of the equation will be only an I. So let me write the equation again. So A is equal to P times 1 plus I. So when we solve this for I, I is inside the parentheses. This is P times, the right side of the equation is P times a binomial, and the binomial contains I. So from this we can distribute. Okay, we can distribute first. So you can take that I, variable I, out from the parentheses. Do distribution property. So P plus Pi. Since we want to find Pi, okay, now let's leave the Pi term on one side. Let's leave it. Pi, because there's one term that contains the variable I. So leave it for a while. So minus P each side so that we can get rid of this P from the right side. Then we have A minus P is equal to Pi. And then we want to find I. So divide each side by P. Divide each side P, then that is I. And then interchange the sides. So I is equal to A over P, A minus P over P. So one of the solution will be A minus P over I. So that's the solution. So when we solve a literal equation, make sure that the variable that you want to solve for should be on one side of the equation, either left side of the equation or right side of the equation. So in this case, I is on the right side of the equation, and then once you find I, interchange the side. So I will be on the left side of the equation, and the expression on the right side will be the solution for this. Okay, example 1. A. Okay, solve this equation for R. Okay, the capital R, the larger R, uppercase R. So the uppercase R is in the denominator. So why don't we remove the denominator by using a cross multiply or multiplying the equation by the denominator, R plus R. So in this case, we can just multiply both sides by R plus R, right? R plus R. R plus R is fine. You can multiply each side by R plus R. Or you can do cross multiply. Or you can do a cross multiply if you are not sure. So this is equal to over 1. So cross multiply. Cross multiply. That means you get I times R plus R is equal to E. So you have this expression. Alright, then from the first one. Alright, then these two cancel out. The right side is cancelled out. Is equal to E. And then distribute. If we want to solve for the uppercase R, So this is r I plus r I is equal to e, and then r I is equal to, look, this is the one we are looking for. We are solving for this uppercase r, this uppercase r. So we will leave this term. Okay, leave that term on one side for a while. Then move Ri to the right. Then you change the sign. When you move to the right, you change the sign always. Okay, when you move a term to the other side, make sure you change the sign. Since this was positive, this becomes minus. Alright, since we are looking for the uppercase r, this is r times I. So why don't we divide each side? Divide each side by I. Okay, divide each side by I. So r is equal to this. Okay, let me write one more time. So I will divide each side by I using, let's use a different color. So I will divide each side by I so that we can get rid of I from the left hand side. And then the left side is I is equal to E minus Ri over I. So this is the solution. So solution R is equal to E minus Ri over I. And then this one you can do the same thing. Alright, let's try letter B. Letter B is now solve. We want to solve the equation. The equation is L is equal to A times 1 plus CT. And then solve this equation for C. Alright, the letter C. So why don't we just distribute CT. C is inside the parentheses, so we will distribute then ACT, right? And then from this we will divide each side by minus each side. Okay, minus A each side. Minus A each side. So that we can move this A. And then the left side of the equation is L minus A is equal to ACT. Alright, then we want to find C. We want to solve for C. So we can divide each side by what? AT, right? AT. So L minus A is equal to ACT. So let's divide each side by what? AT, because we want to solve for C. AT. Multiply by, divide by AT. Then the left side is L minus A is equal to AT. And the right side is, A and T are cancelled out, so we got C. So from this, interchange the sides. So the solution for C is equal to L minus A over AT. So that is the solution. Okay, let's try C. Okay, now we want to solve this equation. S is equal to C minus RC. Okay, solve this equation for C. Okay, when we solve this for C, there are two terms of C's. So in this case, okay, two terms. So why don't we factor out C? Factor out C because we want to solve for C. So combine the like terms. Okay, combine the like terms. And then from this you can just divide each side by what? From this we can divide each side by what? 1 minus R, because we want to solve for C. So let's get rid of this binomial factor. So divide each side by what? 1 minus R. Then finally the left side is S over 1 minus R is equal to C. So this will give us the solution for C. So C is equal to the expression what? At S over 1 minus R. So that is the solution. Okay, problem 1. Okay, why don't you try this one? Pause this and then finish this problem 1. A, B, and C. All right. Okay, we want to solve this equation for L, and the left side, L is in the numerator. Okay, let's get rid of the denominator first. So you can multiply each side by what? 2. Multiply each side by 2, so you can get rid of 2. So that this will be equal to 2s equals A plus L. And L is on the right hand side, so we can just move A to the left. Get rid of this A. So how do we get rid of it? Minus A each side, so that the right side will be just an L. So the left side is 2s minus A is equal to L. So from this, the solution for L is 2s minus A. Okay, letter B. Okay, now we want to solve the equation S equals A plus N minus 1 D. Okay, for the variable N. Okay, now N is inside the parentheses. So first of all, we have to distribute first. So S equals A plus. Okay, write the equation again, and then what we will do is distribute. So S equals A plus ND minus D. Since we want to find N, so there's only one term, ND. So let's get rid of the other two terms, A and minus D. So move A and minus D. Okay, why don't we just move it to the right directly? So once you move A from right to the left, change the sign. So it will be minus A. And minus D, okay, this minus D becomes plus D once you move to the other side. All right. Then from this, what do we do next? Okay, let me write this one again, because the right side has ND, and we want to find N. Right, we want to find N. So let's get rid of this D. How? This is a product, so this is product, and this is a product. So why don't we divide each side by D, so that we can cancel out D. Then what we have is, okay, D, then S minus A plus D over D is equal to, the right side is N. So this will give us the solution N. So the solution N is the expression S minus A plus D over D. So this is the solution. Okay, let's try the last one. Let us see. Okay, now solve S is equal to RS plus C for S. All right, look at this. There are two terms of S. Two terms. Here's one is on the left, one is on the right. So why don't we collect S terms on one side? And S terms on one side, and then combine the like terms. So move RS from the right to the left, then change the sign. Change the sign. Then combine the like terms. Combine the like terms, so factor out S, then 1 minus R is equal to C. We want to solve for S. So how do you get rid of this factor, 1 minus R? Divide, right? Divide. Divide each side by 1 minus R. Then this will give us S equals C over 1 minus R. So that is the solution for S. Okay, number 28. This is an exercise number 28. Okay, solve this equation for R2. Okay, why don't you pause and then try on your own? All right, then let's solve this one. Okay, in order to solve this, we want to get rid of the denominator. So the LCD, find the LCD, which is R1, R2 times R. So that's the LCD. So we will multiply the equation by the LCD so that we can remove the denominators. All right, so the R1, R2, R. Okay, let's use a different color. Okay, let me write the equation first. R2 is equal to 1 over R. All right, so from this equation, let's multiply R1, R2, R each side. R1, R2, R each side. And then distribute, so R1, R2, R times 1 over R1 plus R1, R2, R times 1 over R2 is equal to R1, R2, R over R. So from this, we can get rid of R1. So what we have is R2, R. And for the second term, I'll cancel out R2. So we have R1, R. And the right side of the equation, we can cancel out R. So R1 and R2. Now look at this. We want to solve for R2, right? R2. This is R2. So why don't we collect all R2 terms? This is R2, R2. So let's collect these R2 terms. So look, so which is better? Should we move this R2R to the right? No, it's better. So R1R, and then move R1R to the right. So the right side is this one. Once you move this to the right, it will be minus R2R. Okay, minus, right? Minus, because you move to the right. The sign was positive, so it becomes minus. All right, then from the right side, you have R2, R2. So why don't you factor out R2? Factor out R2 and combine the like terms because we want to solve for R2. Okay, factor out R2, then R1 minus R. And then what? Divide each side by what? We want to find R2, right? R2. So let's get rid of this binomial factor, R1 minus R. So divide R1 minus R each side. All right, then this will be the right side cancel out. So we have only R2. And R1 minus R cancel out. So finally, the solution for R2 will be the expression R1 times R divided by R1 minus R. Okay, that's how we solve the for R2 in this equation.